Hey everyone, Brandon Lee here from Virtualization How To, and in today's video, we're diving into the powerful world of monitoring using what's known as a tick stack. We'll go through what the tick stack is, how to set it up with Docker Compose, and I'm going to show you guys a real-world example of using the tick stack to monitor an environment. So let's get started. First of all, what is a tick stack? Well, the tick stack is a collection of open source components designed to handle the collection, storage, visualization, and alerting of time series data. Tick is actually an acronym that's made up of the first letter of the components it contains, and those components are Telegraf, InfluxDB, Chronograph, and Kapacitor. Each component plays a crucial role in the monitoring stack. So let's get an overview of what each of those components does. Telegraf is an agent for collecting and sending all metrics and events. InfluxDB is well known as a time series database for storing the data that is sent to it via Telegraf or other means. Chronograph is visualization and an administrative interface, and Kapacitor is a data processing engine for alerting and anomaly detection. Altogether, these components form the tick stack. Again, it's a robust and flexible monitoring solution that is not only open source, but it can be used to monitor virtually anything, from server performance to application metrics to even a personal weather station. I'll show you guys a dashboard that I have set up on that front. Now that we have a better understanding of what the tick stack actually is, let's look at setting up the tick stack components using Docker Compose. It's actually very simple, and I will have a link to the written post in the description where I have the code examples that we are going to cover in the video for you guys to copy straight from there. And as you guys know, Docker Compose allows us to define and manage multi-container Docker applications and bring these up as a single application stack. So you're going to need a Docker host as well as Docker Compose installed. And you can use this on a virtual machine or a physical host that you may have set up as a Docker host. You can even use an existing Docker container host, as the resources are not really that much for this application stack that we're going to spin up. So now let's dive into actually bringing up a tick stack and looking at the Docker Compose file that we actually need to bring up this application stack, as well as a couple of other prerequisites as well. First, I want to show you guys my Docker host. So I have a user called Linux admin, member of the sudo users group, and I just want to show you guys the directory structure that I'm working with. So if I do an ls command, you can see I've got a directory called Home Lab Services. Now, if I change into Home Lab Services, I want to ls that directory, and you can see I have already created directories for Chronograph, InfluxDB, Kapacitor, and Telegraf. We can run the tree command. You can see that a little bit more intuitively in that view. But as you can see, I like to organize these Docker Compose stacks with the volume mounts in subdirectories of a project folder. And I'm calling this project Home Lab Services. When I go to mount those volume mounts, I've got those intuitively split out into the directories that I want to use. So let me show you guys the actual Docker Compose code that we're going to use to stand up this tick stack. Let me paste the code in so you can get a better feel for what this looks like. Standard Docker Compose formatting here, YAML formatting, and as you see here, we are simply defining the component containers that we want to use in our tick stack. As we mentioned, it's made up of the Telegraf, InfluxDB, Chronograph, and Kapacitor containers. A couple of other things that you will notice with the volume mount: the Telegraf container and the Kapacitor container both need configuration files, telegraf.config and capacitor.config. And I'm going to link to the written post in the description where you can get example configuration files for Telegraf and Kapacitor, and you can just copy and paste those if you want, modifying as needed. Pretty simple and straightforward stuff. We're just needing the Docker Compose code, and let's see if we can turn up these services with our code. So we are back over in the Docker container host. So what we're going to do is I'm going to create the Docker compose.yaml file, and we are going to paste in the code that we looked at in Visual Studio Code. So now I've pasted that code in. I'm going to exit out, saving the code as docker-compose.yml for YAML. And let's look at this again. We're going to list it out. As you can see, I have the directories, and then I have the docker compose.yaml code. And I've also went ahead and created the configuration files that we need: capacitor.conf and telegraph.conf for config. And I can just briefly show you guys what those files look like. If we look at the first off, the Telegraf config, pretty basic stuff. And as you notice, everything is blank for the InfluxDB. So we could create that username and password if we knew what that was in InfluxDB. However, since this is a new instance, we will attach our instance of Telegraf to InfluxDB after we have stood up InfluxDB, if that makes sense, because we're going to use the API key that it generates as we bring up the solution. So let me exit out of the Telegraf config, go back out, and we can look at capacitor and at C. And let's take a look at this configuration file, a little bit bigger configuration file on this front. And this is from an older installation. I just had a copy of the configuration file, so I will be replacing this API token, but we can leave it in here just so you guys can see where it's actually going. It goes in your InfluxDB configuration, but all of the rest of the configuration at this point is just defaults for capacitor. And this is going to allow the container to be created. However, I do think we will get an error message due to the authentication failing. We'll see in just a moment. So I'm going to save out of that. Let's go back to our home directory and look once again. So now what we can do is we should be able to actually bring up our tick stack. So what I'm going to do is just a simple Docker compose up-d, and let's see what happens. And as we can see, we've got Telegraf, starting chronograph, capacitor, InfluxDB. And now let's take a look at the Docker compose environment and see what status we have on our containers. And as we see here, we've got capacitor that is in a state of exit 1, meaning something has happened. Let's look at that container. And if you guys can see here, we've got a failed to link subscription on startup, invalid response code. And this is to be expected. As I showed you guys in the capacitor configuration file, if you guys remember, we've got the old environment that I mentioned that we need to change this out with current information. So the token that we have here is not going to be correct. And that makes sense that we see the invalid response code 401, which is actually permission denied. So we're going to fix that. Now, the way that we need to correct that is we need to go through the initial setup of InfluxDB, create the API token that we need instead of the old token that is in the configuration file, plug that back in, and then we should be able to bring up our capacitor container. So let's configure InfluxDB. Let's now set up InfluxDB. As you guys can see, I'm browsed out to my Docker container host, and the default port for InfluxDB, port 8086. Now, also of note, you want to make sure that this is an HTTP connection and not an HTTPS connection. It'll actually give you an error if you browse out to the SSL port with this particular default port of 8086. What I'm going to do is simply go through the wizard for InfluxDB. So I'm going to click Get Started. For the username, I'm going to use something simple to remember: influx user, password, and test. for the organization and test for the bucket name. With that configuration in place, I'm going to click continue. Simple as that. The initial user details are configured, and this is the piece of information that we want to make sure that we grab. This is the API token for our user that we just created, and we're going to need that API token for configurations such as the one you saw in the capacitor configuration file. So I'm going to copy this to the clipboard. In addition to the capacitor configuration file, we're going to also edit the Telegraf configuration file. As you scroll to the bottom of that file, you're going to notice this output plugin for InfluxDB. And we know this is using V1 connectivity or authentication since we see a username and password. However, since we've set up V2 authentication with a token, I'm going to paste in the configuration that you guys will need to establish V2 connectivity and authentication with that token file. So you can see here I've got InfluxDB V2. We've got the connectivity and port to our InfluxDB container. And then also I've got the token that we just generated defined in the token parameter. We've got our organization and bucket. So notable differences with V2 authentication from Telegraf over to InfluxDB. So we're going to save this configuration file, and then we're going to, in addition to editing the capacitor configuration, we're going to need to stop the Telegraf container as well and restart it along with capacitor. So let's look at capacitor. So now back over to the capacitor configuration file, and I'm going to simply delete out the token key that was there from the old configuration I had in place, and we're going to paste in the new configuration. And it looks like I grabbed a space there. So this is our new API token. I'm going to exit and save the changes. And now what I'm going to do is I'm going to stop the current capacitor container, and I'm also going to remove that container. And now what I'm going to do is I'm going to go back out to the Home Lab Services directory, which is my project folder. And now, once again, I'm going to run a Docker compose up-d. So now let's run a Docker compose ps. And as you can see, we've got an up on the capacitor container. If we do a Docker logs capacitor, we can see that things are running. We see no error messages, which is really great. And especially not seeing the exit one for the container itself. Check one more time, make sure it hasn't crashed as of yet. So our TIG stack is up and running. And now that we have the TIG stack enabled and we've brought up that application stack, we also need another component to actually visualize the data that we are ingesting into the TIG stack. And the open source solution for that is Grafana. Grafana is a simple yet powerful solution that allows you to basically visualize any type of data. Let's look and see how we can easily add a Grafana container to our application stack that we want to use for monitoring. Okay, so the process to add Grafana to our stack is very, very simple. First of all, I want to show you guys what I have done. I've added a Grafana folder, a Grafana-volume folder that is a child folder underneath there, and that is going to match up with our Docker Compose code that we're going to add to the stack. So I can either at the top or the bottom of the configuration spaces here, and I'm going to paste in the Grafana configuration. And pasting this from another configuration that I have up and running. So I'm going to take out the network that I had configured there. And then as you guys can see, I have the Grafana-volume assigned as a volume mount. And then I'm also putting the user designation in here, as I've had permission issues with Grafana in the past without specifying this user. So I'm just making sure to head off any permissions issues there. So now we just simply need to save and close this file, and we should be good to go on that front. What I can do now is run a Docker compose up-d once again, and we should see that it creates the Grafana container, and that is completed successfully. So we can do a docker-compose ps, and we see that we've got Grafana up and running, which is a good sign. We don't see any exits or crashes there. So it looks like our configuration, our permissions, all of that good stuff should be good to go. Now that we have our tick stack up and running, as well as we've added the Grafana solution to visualize data, let's look at an example of using the tick stack to monitor a VMware environment. And to do this, we're going to use Telegraf to collect data from VMware, InfluxDB to store it, and Grafana for visualizing that ingested data. So the first step to enabling monitoring of a VMware environment using this open source solution, we need to configure Telegraf to collect VMware metrics. And here's a snippet of the telegraf.config file that we're using for VMware monitoring. And this is in addition to the default file that we looked at just to bring up the tick stack. It basically adds another input that it allows us to collect that data and send that data over to InfluxDB. Now, this configuration tells Telegraf to collect metrics from the vCenter server. So we have placeholders in the example code that you will replace with your actual VMware credentials. Now that we have Telegraf actually configured to pull those metrics from our vCenter server and store those in InfluxDB, next we're going to set up Grafana to visualize the data. To do that, we're going to add InfluxDB as a data source in Grafana, then create dashboards to display those VMware metrics. And you can create various panels for CPU usage, memory consumption, network traffic, and many more. But I want to show you an easy way to have incredible looking dashboards for your VMware stack that you want to monitor, perhaps in your home lab or even a production environment. So I want to show you guys how I would paste in the configuration in Telegraf for VMware monitoring from the GitHub page that we just went over looking at that code example. So I've just literally copied that configuration. I'm going to paste that configuration into my existing Telegraf config. Okay, so I just pasted in that configuration, and I'm going to scroll back up and we can take a look at where this fell inside the configuration. As you can see, as we mentioned earlier, it adds a new input for monitoring vSphere. And again, you're going to replace the vCenter configuration with the address of your own vCenter in the home lab or production. And then you're going to provide the credentials for how to connect to your vCenter. And as you can see, we've got all of the default metrics that allow us to monitor various aspects of the environment. So what I'm going to do is I'm going to save out of the configuration and save my changes. And now what I'm going to do is I'm going to stop the Telegraf Docker container, and we're going to remove that container. And then I'm going to go back out to the project folder, and we're going to run a docker compose up-d. Now, you want to know if it's actually pulling data from your VMware environment and getting that into InfluxDB. So I've navigated out to another InfluxDB instance that I've already got set up and configured. It's got a little bit different bucket name, but I want to show you guys what you will see if you go to Data Explorer. And the bucket for this particular environment is called TickStack. And we already see what looks to be vSphere specific metrics. So if I just select a few of those, we should be able to see some data points that are listed. And we do. So we see some data represented by the line graphs here. So now let's go to Grafana, and we're going to be able to set up that connection to InfluxDB. So if I click on connections, I've already got a connection set up. So I want to show you guys what you would do. You would do add a new connection, choose InfluxDB, and let's look at the properties for this particular connection. I've just simply named it InfluxDB. The HTTP URL goes to the InfluxDB container. And then also you want to make sure that under query language you select Flux. Switching to the Flux query language allows you to use the version 2 authentication with a token, and it allows you to configure that token with the token that we set up with our InfluxDB configuration. So you simply enter that information, save and test, and you should get the notice that the data source is working and how many buckets it finds, so you know everything is good to go. Then once you have your data source, it's simply a matter of loading the dashboards that you want to use with your VMware environment. I want to give a shout out to George De La Cruz, and he has done some phenomenal work with vSphere dashboards. and he has actually uploaded these to the community dashboards page for Grafana. So you can literally download those from Grafana to import into your Grafana instance. Now, how do you get there? If you search for Grafana dashboards, the first link past the sponsored post should be the dashboard Grafana Labs link. And you simply search for vSphere. And as you can see, you've got the VMware vSphere overview, vSphere VMs, data store, hosts, and many, many others. So a lot of great resources there. And you just simply load those into your Grafana environment. So if I go to dashboards, new, import, and I simply type in the URL or ID, which the ID, if you click on one of the dashboards, is found in that information. So 8159, you would simply go to your dashboard, type in 8159 and load. Now it's going to tell me that I've already got the same dashboard loaded, but this is what you would do. Once you have that done, you will see your VMware vSphere dashboards that you loaded in. And these are just beautiful, phenomenal information. And all of this is open source and free. And that's it. We've set up the TIG stack using Docker Compose, and we've demonstrated how to monitor VMware environments with it. But the sky's the limit. You don't have to stop with VMware. You can monitor Proxmox, you can monitor other application stacks that you may have. The TIG stack is incredibly versatile, and it can be used to monitor a wide range of systems and applications. And I wanted to show you guys just a simple dashboard that I've created to monitor a personal weather station that I run here at home. I can pull those metrics using the API connection to ambient weather service, store those in InfluxDB, and then I can visualize that data inside of Grafana. There is something to be said for open source monitoring solutions. The TIG stack is extremely powerful, and as we have shown today, it can be used to monitor a wide range of technologies. What are you using in your home lab or production environments for monitoring? Are you using an open source solution as we have showcased today? Let me know in the comments below. Well, if you found this video helpful, please give it a thumbs up and subscribe to Virtualization How To for more tutorials and guides. Also, don't forget to hit the bell icon to get notified of our latest videos. Well, thanks for watching. Stay safe out there, keep on home labbing, and I'll see you in the next video.